Basics of CCNA networking. So we'll start with IP address first of all. IP address means Internet Protocol Address. That's a full form. Internet Protocol. It can be further expanded to Network Protocol. Okay, as the name says, IP address is used to connect inter-network devices, which means whenever you want to connect two different network devices, in that case, you use IP address. It is not for same network. Mostly it is used to connect two different networks. So I can tell I have an N1 network, I have N2 network. In this scenario, you need to have an IP address. Now, what is MAC address? MAC address expands to what? Full form? Media Access Control Address. Now, why do we use the word Media Access Control Address?
Because it is a medium to access the control of the device.
Okay, you just told whatever there. Medium to access the control there.
Medium access the control.
Okay. So basically, MAC address is a physical address. The reason why they have given media access control, because this is the main point through which you'll go inside a device. For example, MAC address will be there in the network interface card. Okay. Now, you guys know IP address are of two types. One is called what? IP V4 and IPv6. And what is the size of IPv4 address?
0 to 2.
Now, in bits, how many bits are there?
32 bit.
32 bits address. In IPv6 is the 128 bit. Okay. Now, what is the size of MAC address? Size of MAC address is 48 bit. Okay. Now, I'll ask you a simple question. How many MAC address are there in one computer? It's a very simple question. 1, 3. Online students?
1, sir.
1. Others?
1.
It can be more than one.
Okay. So the answer for this question is more than 1, because a MAC address will be present not on the computer, it present on what? In the network interface card. If a computer has different ways of communication, for example, I can talk using Ethernet port, I can talk using Wi-Fi, if I have NFC, not NFC, if I have any virtual machines or anything like that, and if I have dual Wi-Fi, like 2.4 and 5, if I have like 2 Ethernet ports. So in that case, each communication done by my PC need to have one network interface card. Wi-Fi needs one NIC card. Separate hardware, obviously, I need, right? Ethernet port needs one NIC card. So different types of communications uses different NIC cards. And these NIC cards carry one MAC address each. So if I'm having 5 NIC cards on my computer, that becomes how many MAC address? 5 MAC address. Equal to 5 MAC address. Now on a Windows machine, you can verify the MAC address by typing get MAC command. You can go to command prompt and type get MAC. If you type that, you can see the number of MAC addresses in the Windows machine. For Mac, I have to use a command called ifconfig. Now here you can see the MAC address showing. It shows ether address 1, 2, 3. No command. So what is IP config/all? I'll Mac mode the kamikuma. IP config/all command pota Mac mode kamikuma ellame kamikuma. Ellame kamikuma. IP config/all command கொடுத்தீங்கன்னா that shows you everything. But get MAC command கொடுத்தீங்கன்னா it will show only the MAC addresses. வேறு காமிக்காது. It will clearly tell you how many MAC addresses I'm having. These are the MAC addresses. But this command is for seeing everything: IP address, MAC address, everything. Next, we'll talk about the 3 different devices we are having in networking. One is called hubs, switches, routers. Now, what is a hub? Hub is I can call it him as a brainless device because it is not going to think anything. Like imagine that, yeah, whatever data you are sending, it will simply transfer it to someone else. That's all the hub will do actually. It is not a security.
Data, the data we can add the
Clarify.
data from the data you know.
First English la vanda, adukapra English simple aayita, ipo Tamil la poita fulla. So there is no security features in hub. So you can compare hub with this kind of hubs actually. You might have used USB hub, right? Does this USB hub have any kind of brain in it? It doesn't have any CPU and all. So if a product which doesn't have a CPU, that becomes a brainless device. Similar way, your hub, whatever I'm receiving, I'll simply transfer it to everyone. It's always broadcast device. Talking about switches, it has brain in it and it can do both broadcast and unicast. Whatever traffic I'm receiving, I can send it to one person or I can send it to everyone also. Talking about router, again it has brain and it always supports only unicast. Routers do not do broadcast at all.
So unicast and multicast.
Multicast by default is there actually. No, routers always unicast. Now we'll understand how switch works. Before that, we'll understand about duplex settings of hubs and switches. So hub is a half duplex medium device. When I say half duplex device, which means hub can either send or receive traffic through different ports. For example, I am connecting 2 devices to a hub. Appo enna avuna and the device la vandu either one device can send or other device can receive it. Both the tasks cannot be done at the same time. For example, here you can see I have like 2 devices connected to a hub. I have device A and device B. Device A, when it sends traffic to device B, at the same time, device B ala traffic inga anupa mudiyadhu. Only one-way communication because it's a half duplex device. If you talk about the switches can be a full duplex also, or it can be half duplex also. If I'm connecting 2 devices, if PCA sends traffic to B, at the same time, B can send traffic to A. Both the way it is possible. You send and receive at the same time because it's a what? Full duplex device. This is what?
Half duplex.
Half duplex devices. Router is also full duplex, which means I can also send and receive packets at the same time. Now, the major comparison between switch and router. See, I have LAN. You always compare LAN with a street. You have a street. Imagine it's a street. Normal teru, okay? This is main road. You have this road. Here you have houses. See, routers are like traffic signals. So whenever 2 streets connect, right? In this area, you will have routers. In this area, you will have routers. Routers actually help you to route the traffic from one network to other network. It is not used for same network. It is used for relative. MAC address. Why do we use MAC address? MAC address is used to communicate within the network. So imagine switch will be here actually. Switching here. Locally, you switch packets within the network. You use what? Switches. So always think routers will be placed at the edge of a network, and switches are within the network communication. You can imagine this room as one network. If we want to communicate, we use a switch. If you want to go outside your network and talk to somebody else, you have to use a routers. And switches uses MAC address and routers uses IP address. And switch has something called MAC address table and router has something called routing table. Now we will learn how switch communication happens over the network. We'll talk about how router communication happens also. अरे कोई जान क्या कर अरे कोई जान बोलना Now we'll learn how the switch communication happens actually now, followed by routers. So I'll try to make it very easy so that you understand in a very better and easy manner. So topic name is how switch communication works. Imagine that you have 4 PCs. I have PC1, PC2, PC3 and PC4. PC1's MAC address is AA, PC2's MAC address is BB, it is CC and DD. See, whenever a switch receives a packet or a frame, so whenever a switch receives a packet on any one of these port, switch will do 2 functions actually. First, switch informs MAC table about the source MAC address and the port number at which I arrived. Second, switch will ask MAC table, hey MAC table, do you know how to reach this destination address? So, once I receive a packet, officially we call it as frames. When I receive a frame on the port or packet on the port, switch immediately will go and inform the MAC address table about source MAC and the port. Then switch will ask MAC table, do you know how to reach the destination address? Let's see. Imagine that PC1 want to communicate to PC2. When PC1 sends traffic to PC2, what will be the source MAC address? When PC1 sends traffic to PC2, what will be the source MAC address? Source
number?
AA,
Destination MAC will be what?
BB.
So this traffic will come all the way to which port number? Port number E1. So whenever my switch receives a packet, first function what I'll do, I will go and inform the MAC address table. Hey MAC address table, I received source MAC of what? AA on which port number? E1 port number. Once I write it here, then I will ask MAC table, hey, do you know how to reach the destination address BB? Do you guys see entry of BB here anywhere? No. So by default, imagine that you're going to a classroom. In that classroom, you don't know who is Arun. What you will do? You will shout and ask everyone, right? Hey, who is Arun here? But that same you will do. Because you don't know about BB, I will send to everyone. Will he respond back? No. Will he respond back? No. Will he respond back? Yes. When he responds back, what will be the source MAC address?
B,
BB. What will be the destination MAC address?
AA,
So this packet comes all the way to which port number?
E2,
Which will do two functions. It will first go and tell, hey, MAC address table. Now on E2 port number, I received a source MAC of BB. Once I inform to him, I will ask him, hey, do you know yeah, right? I'll go and ask him, hey, do you know how to register MAC address? Here? Yes, it's on E1 port. So the reply will be unicast. Reply will not be broadcast. It's like you called Arun. Arun heard that you are only calling him. So he will reply unicast, right? Again, he will not shout, hey, I'm only Arun to everyone. Same happens here. So this MAC address table is gradually learned and processed. It's not a one-time work. It's gradually processed.
But sir, the message went to every PCs, right? Means first time it went to every PCs like PC3, PC2, PC4.
Yes, it went to PC2, PC3, PC4. Correct. Yes, it went. What is the question on that?
Yes, but in that case, it is also not safe, right? Means in for the very first time it broadcasts. So
Yes.
the message went to everybody.
Yes.
So in that case, it is also not safe. That's what my confusion is.
Yeah, it is not safe. That's how switch operates. We cannot change that stuff and all. That's how it behaves.
Okay, sir.
Yeah. And you don't need to worry about it because it's a local switch. And you are only connecting those PCs. It's physically present next to you only. So you know which PCs are connected. It's not a router. And traffic is not going to the internet now.
Oh, yes, yes.
Understood? Now, the same way, we will learn how the routers forward a packet. We'll talk about the routers now. That's it. So to explain routers, I use a postman story. Let me explain you how routers forward a packet. So before we talk about the actual physical logic of routers, let's think about two people, DJ and Vicky, and they stay in a long distance and they want to send a letter to each other. So when DJ prepares a letter and he will write from address and to address, right? From address will be whose address? To will be, please note that to address will not be the postman's address, correct? It will be Vicky's address. The logical address is always destination's address, not next hop's address. So now Vicky, a DJ will write from address and to address on the letter, and he will give it to whom? Physically, he will give it to postman number 1. Now postman 1 will see what address to deliver, from or to. He will see to address and observes that this area I don't cover, it is far away from me, but this postman covers it. So physically, he is going and giving letter to him. Postman number 2. Are we changing from and to address on the letter? He will receive the letter. Now he will see which address, from or to address? To address he will see. Again he will check the to address, observes that it is Vicky's address. And he goes physically and gives letter to Vicky. Now Vicky will check which address, from or to address first. Vicky will check to address first to confirm it is for himself or not. You have to do same thing, right? Once you get parcel, immediately you not open it. First you will check whether it's for you or this. Check பண்ணிட்டு தான் அப்புறம் you will see from address யார் அனுப்பிச்சானு அதுக்கப்புறம் you open the cover. So you can see physical movement is happening, but on the letter the logical address is not changing. Same applicable on normal communication. We have PC1 and PC2. PC1's IP address is 10.0.0.1 and PC2's IP is 20.0.0.2. Now PC1's MAC is XX and this router's interface MAC is AA, BB, CC, DD, YY. Now when PC1 want to send packet to PC2, what will be the source MAC address? Sorry, what will be the source IP address? It will be 10.001. What will be the destination IP address? 20.0.0.2. That will be a destination IP address. What will be the source MAC address? Physical MAC address will be. Destination MAC will be what? It will be AA. You can see physical we are giving to him only, right? If we say AA mean, if we see YY means he will go directly and give it to him itself. That's not happening. Physical address will change. So my physical address will be XX to AA. This byte comes all the way to whom? Here. Now R1 receives the packet and sees destination MAC is my MAC only. So I'll open the cover. Inside it sees destination IP is not my IP. It is someone else's IP. Then again it will re-encapsulate here packet. I will put the cover again. Now I will put the cover again. Source IP will be same. It won't change, right? And the letter from address to address didn't change. Source IP will be 10.001. Destination IP will be source MAC will be what? BB. Destination MAC will be what? Next hop MAC address. So traffic comes all the way here. R2 sees destination MAC is my MAC. Oh great, I'll open the cover. But unfortunately inside destination IP is 20.001. I'm not 20.001. So I will check into my routing table and I will again re-encapsulate the packet. So packet goes from here to here. Source IP will be what? Same 10.1. Destination IP will be what? 20.1. Source MAC will be what? Destination MAC will be what? So by this it will goes here. So as you can see, in the entire travel, when the router comes into picture, your MAC address will keep on changing. Okay, router's IP address will not change. Your MAC address will keep on changing on each and every router's hop. Now, if you guys have any question, please ask me now. No?
In home network, we are connecting both, like we are using Wi-Fi and we are using like some other vendors like ANT, ACT, whatever it is. So how it is connected, sir? Like switch and router both is connecting in home network also.
Have you understood this concept?
Yes, yes, this concept I understood, sir.
Great. Now ask me your question. What was your question?
Like in home, like we are using others vendors like ACT, ANT, and how they are using means how they are connected the network in home.
You have a home PC connected to your home router, connected to your ACT or
Uh,
a modem. Now, what's your question in this?
how this is working, sir? How this is connected? How this is working? That my doubt is that.
Okay. So for this to explain, from here to here, the packets are coming using IP addresses because your PC will have an IP address, right? Maybe 10.0.0.1. And do you know what is default gateway?
No, sir.
Okay. So my router's port will have a port number, right? That port will have IP address. That IP address will be my default gateway. So if you want to send traffic anywhere outside your network, by default, I'll send it to my default gateway, and default gateway will receive it, and it will, by default, this router will have the information saying to send out the packet to any network, send it to him. So by default, all traffic will go via him only. To understand this better, you have to finish at least 50% of your CCNA.
Okay, sir.
Correct.
Okay, sir.
Next, we will see for it to exam. So we have seen two things. One is called how switches communicates or works, and how routers communicates or works. Next, we will see some of the basic common terms. Okay, one is called static routing in CCNA. We'll talk about dynamic routing in CCNA. See, in routers, there is a table called routing table. Routing table is there in routers. If your IP is present in the routing table, only then you can ping that IP. Only you can reach that particular IP address. Imagine that you have R1, R2, R3. My IP address is 12.0.0.1, 12.0.0.2, 23.0.0.1, 23.0.0.2. See, in R1 router, this 12.1 is physically connected, right? Okay. So in the routing table of R1, by default, I can see 12 network and all because it's physically connected. It's my port. So can I ping 12.1? Yes. Can I ping 12.2? Yes, because via this port, I know I can connect here. But from R1, can I ping 23.0.0.1? Because it's not directly connected. It's somewhere else. I don't even know how to reach it. So in this case, how can I reach him? You either use static routing. What does that mean? You can go to R1 and you can tell IP route to reach this network, go via this IP address 12.0.0.2. It's like you are living in this Chromepet area. You guys know how to go to Chromepet station, but you don't know how to go to Tamram. If I tell you, go via Tambaram Sanatorium, you can go, right? I cannot, it's next stop. Maybe you know where is Tambaram Sanatorium, next stop. So, similar way, to reach this entire network, you can tell routers to go via this port. So traffic can go from here to here and here and all. Similar way, R3 don't know how to reach this network, right? Not directly connected. So I can go to R3 and tell to reach this network, next stop is this. So only if you confirm these informations, they can probably reach each other. But the problem with static routing is that the number of lines of commands you're going to write. For example, I have R1, R2, R3, R4. Imagine I have 5 routers. So I have to tell him how to reach this guy, tell him how to reach this network. I have to write 3 times, right? Command here, because he only knows about this network. So you have to manually tell for other networks. Similar way to him, how many lines I will keep writing? He don't know about him, 1, and then him also 2. Then for him, he don't know about him, 2. He don't know about this guy also. So we have to write that many lines of configuration in static routing. Imagine you have hundreds of routers went to a toss. So you cannot do that easily. It's very impossible almost to configure, because you have to give path. You have to tell for that network go via him, to that network go via this router. Like that becomes hard. That is why we went with something called dynamic routing protocols. In dynamic routing, we have different types. We have RIP, we have EI, GRP, we have OSPF, we have, that's it. RIP expands to routing protocol. Enhanced interior gateway routing protocol. Open shortest path first. Okay. So let's understand how does this work in basic terms. I'll explain about OSPF. Imagine that you have R1, R2, R3. Now OSPF is like a protocol. Like protocol means it's, I'll tell you. Imagine I have 10.001, 10.002, 20.001, 20.002. Once I enable OSPF here in this routers, all the IPs will go into a bucket, and that bucket name is LSA, link state advertisement. Similar way, once I enable OSPF here, all the IPs will go into LSA, link state advertisement. I enable OSPF here, all the IP goes to where? LSA. So you enable OSPF on these routers in simple command. Once you enable OSPF on these routers can actually communicate or talk to each other via that protocol, and they will exchange these buckets. Now these buckets carries what? These buckets are carrying what? IP addresses. Ultimately, I am exchanging IP address now. So by through OSPF, it becomes more easy and faster way to exchange the IP address between routers. If I start exchanging IP address, is it true that this IP from here will go here also, right? This IP will go from here to here also. So ultimately, without configuring static routing, I am exchanging the IP address, so I can easily ping. Don't try to go deep dive on these topics because these are very hard topics. I'm just giving you 5% of what topic is all about. Just an introduction about what to expect in that topic. Next, we'll talk about something called ACL. What is ACL? Expands to access control list. Now, why do we use ACL? ACLs are used to permit, deny, or mark a traffic. Let's imagine that you have a PC, one more PC, they're connected to a switch, go into a router, go into another PC. See, by default, PC 1, 2, 3 is there. I want PC 1 to be able to ping PC 3, but I don't want PC 2 to be able to ping or reach PC 3. I want him to send traffic to him, but not him. In that case, you can configure ACL here. In ACL, I can tell, hey, ACL, if source IP is 20.002, then you deny the traffic. If source IP is 20.001, then you permit the traffic. In simple terms, I can tell like that. So we can either permit, deny traffic. And where do we configure ACL? On routers. On routers, we configure ACLs. Again, I'm telling, we're just saying 10 or 5% of all topics. We're not going deep dive. Next, dynamic host configuration protocol. Now, what is DHCP? See, to configure IP address on PC or any end devices, it can be a server, wireless AP, it can be even your watch, mobile phone, TV, any smart device also. To configure IP address on these devices will hardly take 2-3 minutes, right? You can go log into the device and configure IP address manually. But what if you have thousands of PCs? In that case, it becomes a very big job to configure IP address itself. So in that case, what I have to do? We can use DHCP. DHCP means dynamically configuring the host with IP address. So DHCP is a server basically. In the server, we'll give a pool of IP address 10.001 all the way to 10.00. Bulk kana? ஒண்ணு கூட பண்ணலாம். டிஃபரெண்ட் ஐபியும் போடலாம், ஒரே ஐபியும் போடலாம். ஒரே ஐபினா புரியல. அப்படிதான் சேம் சப்நெட். சேம் சப்நெட் இருக்கு சொல்லு. சப்நெட். That means same subnet. ஒரே IP இல்ல. Same subnet or different subnet. We can use DHCP server to provide same subnet also or different subnet also, both. So if இவ்வளோ PC இருக்குன்னா, from they will be connected to a switch, and from here everyone can receive IP address, and they will be getting unique IPs only. They will not get duplicate IP addresses. Now DHCP is a server to provide IP addresses to the end devices. Okay, that's called DHCP. Next, NAT. NAT expands to what? Network address translation. So by default, in the IP address, we are having two types. We have private IP and public IP. Private IP address segments, they cannot reach internet. They can reach internet. So basically, if my PC is having a private IP address, it cannot go online. If my PC is having a public IP address, it can go online. But what if I have a PC and it's having a private IP of 10.001. If you still want him to go online, in that case, you can configure network address translation in the router. Now, NAT is used to convert a private IP to a public IP. Because public IPs can go online. So, NAT is used to convert private IP to a public IP to go online. And it can do vice versa also. It can convert public IP to private IP also. Both it can do. That's called your NAT. So this is all about your basics, guys, which I have covered. Again, I'm telling you, I have not taken any topic in deep. I just covered 5 to 10% of that topic. Okay. Now, if you guys have any specific question on any topics, please ask me now. All in students, Balakrishna, Bhuva, any questions?
No question, sir.
Vasant, Purnima,
Clear, sir.
Yoni, Mulipur. Any questions? No questions? Fine, guys. Thank you.